Once again, welcome you all of you the lecture series of the Microprocessor and Microcontrollers. Now we are in the sixth chapter called the programming in C for replicating controller. Okay, we are programming the replicating controller by using the C compiler. So as of now, we can program the 8086 microprocessor or 8051 microcontroller. We are using the assembly language programming. But here, PIC18, it is also possible to programming the PIC18 by using the assembly level language programming. But why can't we programming the PIC18 for the C programming? Then we can see the what are the some advantages of the programming in C for PIC18 over the assembly language programming and all we can discuss in sixth chapter. Okay. Now today's topic is what are the different types of data. Whenever you are talking about the C, you must learn the what are the different data types that are available in the C program. We can know the data types. It is very much easier to write the programming in C. Okay. Now see. This is the sixth chapter topics. So what are the different data types, IO programming, logical operations, and data conversions. So four topics are there in the sixth chapter. Okay. So now today we are going to discuss the first topic, data types. Okay. Now you know that the basic structure of the PIC controller, PIC18 controller or whatever controller. So this controller will follow the Harvard architecture. So nothing but there are separate. See this. There are separate address and data lines are dedicated for the programming memory. At the same time, there are separate address lines are dedicated for the data memory. Data memory here, a separate line, separate bus is a separate bus is allocated for data memory. At the same time, a separate bus is allocated for the program memory. So here, see this. Whenever you are talking with the memory, see this in 8086 microprocessor, combinedly you have both RAM and ROM. But when we are talking about the 8051, we are talking about the program memory as well as the data memory. We'll come to the PIC18. These separately have the program memory as well as the data memory. See this difference between. Combinedly, you have the program as well as data memory in 8086 microprocessor, but 8051 it is combinedly, but it is separated by the program memory as well as the data memory. In PIC controller, it is separate program memory as well as separate data memory. This program memory of ROM is nearly 2 MB in the PIC18. Okay, so our intention is to why we can programming the PIC18 in a C programming, C language. You know that very well. C language. Why? What is the reason? Why we are coming to the C programming to write the PIC18 programming? So assembly level language programming is also there to write the PIC18 programming. But why you are coming to the C? There are some specific reasons behind that one. See this. First, suppose by using the assembly level language programming. So how to they, so this is the human level language programming. A human being is right to that. There is some compiler or assembler. In C level language, you can call it as a compiler. In assembly level language, you can call it as assembler is there to convert the machine level language. You can also call it as hex code. Hex code. This is the human level language. Human level language to the a compiler is there. Compiler or assembler is convert some human level language to the machine level language or X code or X file. You can call it as X file. So this where this X file is stored. So this X file is stored into the download into the ROM. So ROM of the PIC18 controller. So the size that will be produced by using assembly level language program is very small. Here the main reason for using assembly level language programming is the size issue, because we are using the program memory of the PIC 18 is very small. It is of only 2 MB, 2 MB, a limited space, a limited space. Program memory is a very limited. So PIC 18 it is limited to the only 2 MB, 2 MB program memory, very limited space. While we are using assembly language program, you write the programming, it will take the very less space or nothing but it will generate the a smaller X file when compared to the C compiler. So that is the one of the main advantages for writing the programming in assembly level language. But why are we coming to the C? See, how does the choice of programming language affect the compile size? So see this first point. While we are using assembly level language programming, it produces X file is much smaller than the C. Yes, that's why you are using assembly level language programming. But it is so very complex as well as time consuming process, a very tedious process and time consuming process. So more number of instructions we are going to write for performing some single operations. So at the same time, while writing the programming in C, so it is less time consuming as well as much easier to write the program. But the drawback of writing the C programming to the PIC 18 is it can produces the uh, X file is much larger than the X file produced by the assembly level language program. Okay, so by considering this factor, less time consuming as well as the much easier factor, we are going to write the PIC 18 in programs in C language. Okay, so there are some reasons. See this. There are some reasons for writing the PIC 18 program in C language instead of the assembly level language. So it is easier and less time consuming. At the same time, it is easier to modify and update. It is very important. It is easier to modify and update. But suppose if you write the assembly level language programming, so it is somewhat tough to modify once you executed that program. You come back to the current instruction and current address location. It is somewhat a tedious process and it is somewhat a time-consuming process. So, but in C language, it is very much easier to modify that program as well as the update that program. So we can use code available in the function libraries. So function libraries. So the same time, so C code is portable to the other microcontrollers. The little are no modifications. So but see this 8086 microprocessor assembly language programming is not suitable for 8051 microcontroller, are not suitable for PIC 18. There are separate assembly level language program you have to learn for 8086 microprocessor, at the same time 8051 microcontroller, at the same time PIC 18. But when you know the C programming, so that is enough for writing the program for all the type of the microcontrollers. But when you see the assembly level language programming, the syntaxes for are nothing but the instruction format for each and every microprocessor as well as microcontroller is varies. It changes. The instruction format it changes. For suppose for I am represent for example some move immediate some a comma 05. So this is the move immediate in the 8086 microprocessor. That whatever the data that is available in the that is 05 is moved to the register A. So in 80 microcontroller, I write the move a comma some data, for suppose you, for suppose you. This data is moved. See this difference. The same syntax. See the meaning is same. The 05 is moved to the A here. A here. See this. Here 05 moved to the A here. But what is the syntax of this? Mnemonic for this. This is MVI move immediate. This is move instruction. So by varying the device, the assembly level language program is also changes. But when you write the code for in C, even though the device is changes, due to the little bit modifications we are going to changes, and without any modifications we are going to use in the other devices also. That is, so these are the some reasons for coming to the C programming for PIC 18 controller. So once, so see our main topic is data types in C. Once okay, we decided that you write the programming PIC 18 for by using the C language. Okay, what is our main constraint here? What is our main constraint or main drawback while we are writing the C programming is it can produces large X files, but the program memory is small size. Small size. It is only of 2 MB. So we can keep it in your mind. These 2 points. We are going to write the programming in C. So once you so nothing but large X file and the program memory very small, you reduces the X file size and better to utilize the 2 MB memory. You have to know the what are the different types of data types that is available in the C programming. When you know the data types or how to use the data types, so you may be write the small X files to execute the program. So here these are the different data types that are used in the C language. Character, signed character, unsigned character. You see this? So remember once again, the PIC 18 is a 8-bit microcontroller. Okay, 8-bit microcontroller, remember. So 8086 is a 16-bit, 8051 is a 8-bit, PIC 18 is a again PIC 18 is a 8-bit microcontroller. Remember this carefully. Okay. So unsigned signed character, unsigned character, int, unsigned int. You know the short, unsigned short long, unsigned short long, long as well as unsigned long. See these characters. These are 8-bit characters. So 8-bit, the maximum number is 127, minimum number is minus 128. You know the ranges. So signed character is 8-bit again minus 128 to the 127. Unsigned character 0 to the 255. Okay, 0 to the 255. Its integer value is coming to the series 16 bits. See the 16-bit integers are available. So at the same time, short and long as well as those are the 24 bits as well as 34 bits are available. You know that simply are 2 power. Simply simply you can convert into the power. Okay, see this 120 minus 128 to the 127 bits are available in character. In signed character is minus 128 to the 127. So unsigned character 0 to the 255 are available. So 0 to 255 are available. Okay, so again integer values is minus 32,768 to the plus 32,767 are available unsigned. So see this. So as signed, we are using these instructions frequently. These 4 instructions frequently. Most of the instructions we use is unsigned character. What is the signed as well as unsigned? See this, whether we are representing signed is minus number, then unsigned is some positive numbers. What is it? So microprocessor or microcontroller can perform the operations by in signed binary operations and unsigned binary operation. or signed binary. See this. For suppose if it is 8-bit register is there, so this is D0 bit, this is a D7 bit. In signed binary operations, this D7 bit is used for the signed operation. That nothing but if it is equal to the -1, it is the positive number. It is nothing but the sorry, it is 0. Sorry, again, it is 0. It is a negative number. Positive number. If it is a 1, it is a negative number. This is signed operations. So what is the register size? It is 8-bit only. Out of 8-bit, 1 bit is assigned to the assigned to know that whether it is a sign, whether it is a positive sign number or negative. Sign means a positive number or negative number. So out of 8 bits only, you can utilize this 7 bits only. 7 bits only. So this 8-bit is dedicated to the either 0 1 for nothing but we have to know that whether it is a positive number or negative number. But in unsigned operation, so there is no necessity for whether that is a positive number or negative number. So D0 to the D7 bits. Nothing but 8 bits we are thoroughly utilizing. That is the main difference between the signed as well as the unsigned. Okay, the signed character. So whether you are using signed character, once again you should remember the default one is signed character. Whether you want to programming in unsigned, then only you can represent an unsigned character. Otherwise, it will, or suppose you represent the char, it will take the signed character, nothing but a negative as well as positive. So whether you want that without any notation, nothing but the positive or negative, then only you can utilize the unsigned character. The advantages of using unsigned character is we are utilizing 8 bits thoroughly. We are using signed character, you can only use the 7 bits of data. The 8-bit data is not possible. Okay. See this unsigned character. So this is the most a natural choice for many applications. So the size is 0 to the 55. So it's mostly widely used data type for PIC. So it is used in many situations like counter the value. There is no need of signed data. Signed data means a positive number or negative number. Okay, remember that C compiler uses signed character as the default value unless you can represent the unsigned character. Okay, see this a small programming by using the unsigned character, very small programming, right? C18 program, see this, most of them they may be writing PIC18 program or C18. So C18 means why you are using C, because we are using C language program to write the programming the 18 PIC18. So that's why they may be represents the C18. There is no wrong. It is so some cases they may be represents the C18 or some cases they may be represents the PIC18. Both are same. So write C18 program to send value 0 to the FF is nothing but 0 to the 255. So this is the hex value. This is the hex value. This is the decimal value. This is the decimal value to port B. So nothing but you can just so port B. So what is the port size? Again, the port size is only of 8 bits. D0 to the nothing but B0 to the B7. Port B. So whether the port B is input port or output port, you can send that value. Sending means output port. Output. So we have the ports are there, different ports are there, port A, port B, port C, and so on, port N in PIC18. But that how many ports we are using the PIC18 is mainly depends upon the number of pins of that PIC18. So the some PIC18 we have the 24 pins, some 60 pins are there, some 80 pins are there, some 72 pins are there. So based on that number of pins, these ports are changed. Here our question is can send the value 255 value to the port pin. Nothing but ascending operation means a write operation. A write operation. So write the operation we have to perform. Nothing but port B is a output port. Port B can work as a output port. Write the operation. Receiving means port B is work as an input operation. But here we can send the value is nothing but the output operation. So what is the port size? How many? What is the port size register? Is only of 8 bits. Only of 8 bits. So the ports that are used in the PIC is 8 bits. Remember. Maybe for suppose they can given in the 16-bit data to send the port A and port B. And that time it can divide into the so 16-bit data to the 8 bits, then store in the different ports as port A, port B, or port B, ports or whatever they can use. So here the question is write the C program to send the 255 value to the port B. Nothing but so a port B is work as the output port. So a port B is 8-bit port. Remember, always it is always these are the 8-bit ports. So to write the 255 value to the port B. Remember, so reading and writing, both operations are similar for any of the microprocessor microcontroller. So you can perform the write operation here at the same time output here. So same, you know that in C program, whenever you want to write the programming, you know that you must write the hash include C here. This is the configuration of the the type of PIC18 we are using. We are using here PIC18F448 is the model of the remember is the model of the PIC18 controller. F is indicates the flash memory. A flash memory type PIC18 we are using. This is the model number. PIC18F458 is the model number of the PIC18 controller. So this will gives the some we can call the some files to execute the program. Then main we are using the wired main, nothing but so once you represent the main on that one you are representing the program. This is our main program. This is our main program. So we are using unsigned character here. Unsigned character, nothing but an unsigned character. What is the value of this one? 0 to the 255. They can given the 0 to the 255. 0 to the 255, or otherwise they just simply send the 255 value whatever from 0 to 255, 255. So you can take the unsigned character. See this an unsigned character we are using here. So for the same they can given write the C program for sending the 0 to 255 to the port B. You must use the unsigned character only. Whether you use the signed character, you should only send the 127 positive data or minus 128 negative data only. Only you can send the 7 bits data, not the 8 bits data. Okay, so you must remember this table carefully. Okay, see this programming. So this is the this will you know that this is the comment. This will gives the port B is a output port. Port 0 TRISB, this is port B. So you know that whether you converting these ports for port A, port B, some one mode to another mode, nothing but input to the output. We are using the latches. Okay, some latches, some devices, some tri-state logics. So that's why they represents the TRISB is equal to 0. Either 0 is output, 1 is 0 is output, 1 is input. Remember, whether represent for suppose we mistakenly written is 1, we will take it as a port based input port. So on the time it is not possible to it's not possible to load the data to that port. So as 0 is output, as 1 is input. Remember, when you represent this TRISB, try some logic. B is equal to 0, then port B is the output. See this comment. Port B is the output. So they can represent 0 to the 255 value. That's why you write the for loop for this one. Z is equal 0 to the Z less than or equal to 255 value. See this and Z plus. We can increment that value. Z plus. So 255 value only. Simply 0 to the 255. We are using signed character. On that time, it is only possible to write the either 127 value only. So see this. So this value. So this value, Z value, see this Z value, you can assign this value for loop, you can Z value to the 255. So this Z value is loaded into the port B. So Z value is loaded into port B. Port. No, no, we can written the while otherwise. So this logic is fails. Again, it is written to this case. A very simple program. You know that very simple. Okay, so you know that how to write the C program. For suppose you can add the two numbers. For suppose addition, add the two numbers. Add two numbers. Simply add the two numbers in C program. I'm using C program, not for PIC. How to write include std io dot h. One is then main program here. Main. Then you can start the program. Then you can take the integer value. What is that value? Or integer value, some value, some integer value, some for suppose some character, some integer value 3, integer value 3 or integer value 5 or whatever it may be. Or otherwise, I represent the some character A, character B, character A as well as the character B. So this will be as a signed character. Okay. Okay, then you know that there is some printf function is there, some scanf function is there, as well you can write the end program. So whether you so again you have to represent the some C equal to the A plus B form, some print C value. Scanf, so scanf function is used to assign the values of, for suppose character A equal to 5, B equal to 2 here. So C equal to A plus B. What is the answer is here? 7 is the answer. So likewise, we are representing, you are writing the program being for a microcontroller, PIC microcontroller. That's why we can calling it as a program libraries of this. This will give the can assign the libraries of this PIC. So very easy. So you can take some character Z. So that will be used to assign the value 255 value. So we can make the port B is the output port here. Then what is the value they can go into introduce 0 to the 255. That's why you write the logic for z equal 0 to the z less than or equal to 255 and z plus. You can assign port B to the z. It is port B is equal to z. So that value 255 value is loaded into the port B. Again, signed character. Whether we are using signed character series. So this is also the 8-bit and 8-bit. For suppose this is D0 bit, this is D7 bit, D7. This is LSB, this is MSB. This MSB bit is used to the signed character, signed bit. You can call it as a signed bit. It is 0, false to, is 1, negative. 1 negative. So effectively we are replacing only 7 bits. This is 8-bit register. This is 8-bit register, but this 8th bit is the most significant bit is used as a signed bit. So the 0 is false to 1 is negative. So you can only use this 7 bits only. So this is the default character for the C program. So the values ranges from -128 to the +127. We are using only effectively 7 bits only. Okay. See this. So write the C program to send values -4 to the +4 to port B. Again, sending. So nothing but port B is output port. You can perform the write operation. Whether you see these values minus to the plus value, you must use the signed character. Or simply here the same program they can give in the write C program to send the value plus 4 to the 4 to the port B. On that case, we may be use the unsigned character, but they are specifically using minus 4 to the plus 4 value. So that's why you must use the unsigned, signed character only. In signed character only, you must represent the positive as well as the negative number. The signs of that any of the digit. Sign means either positive or negative. The same program here. The same program here. The same program we are using. So this is of unsigned character we are using the signed character. Again, you can include this libraries of this PIC 18 type of the microcontroller. Then you can use the main program here. So character, see this character. Simply use the character, assigned character. My number, what are our numbers? Minus 4 to plus 4. Nothing but minus 1 is there, minus 2 is there, minus 3 is there, minus 4 is there, 2 plus 4. Plus 1 is there, plus 2 is there, plus 3 is there, plus 4 is there. So that's why all the numbers I am specifying here. All the numbers again I can assign the value set. I'm assigning the value set. So this is the output port. Making for z equals 0, z less than 8 values. So it represents how many values here? 1, 2, 3, 4, 5, 6, 7, 8 values are there. So that's why I write the z less than 8. Then z plus plus. So port B is equal to the my number z. So z, you can assign all these values to the z. You can assign all these 8 values to the z. So that's why you can consider the unsigned character as z. Remember, so we are taking signed characters as a plus to the minus. You can assign all these values to the z. So that's so again simply you just put port B to the z values, my number z values. So you want to know that what is z value. You know that you tell that microprocessor what is z. So that's why you represent an unsigned character z. So where you can assign these values, whether you assign these values to any of the character or any of the letter A, B, C, D, or not only using Z or any of the characters from A to the Z values. So you must use that Z character. I mean unsigned character value. So this is the port B is a output port. So this is used to limit for the value of the Z. How many values we are using for the Z? Only 8 values. Otherwise, we are using, for suppose we are using as 9. So they may be it can show the any of the null values. Okay. Same case for suppose we are using the integer value. Remember here, the integer we are using it is a 16-bit. 16-bit data type. And integer is a 16-bit data type. So what is the range of this one? This is this one. 0 to the F. This is nothing but the 2 power 16 is nothing but the 64K value. So 2 power 8 is nothing but the 255. Yeah. Okay. 64K value. See this. So an unsigned int as well as signed int. Two are there. Unsigned int as well as two. So here the unsigned int is used to define 16-bit variables such as memory addresses. At the same time, this unsigned int is also used to set counter value of more than 256 value. So what is our limit here? Only 255 value. 0 to the 255. Nothing but you can count that one 256 values. So more than that, for suppose we are using unsigned character. What is the range here? 0 to 255 only. Now, because it is 8-bit. If you count the more than that value, for suppose 300 value they can give. You can count the numbers 300 or more than that value or more than that some set count value. And that time we are using the unsigned character. But remember, this microcontroller is a 8-bit microcontroller. But the available unsigned int is a 16-bit type. So that's why you take it into the 2 bytes of the RAM is nothing but so 8 bits. You can use it as a 8 bits. Okay. So assigned it. So this is also the 16 bit. So that so it is represents the negative to the positive value as well as so one number is reduces out of 16 bits. See this D0 to the D15. This is used as a signed bit. So only you can effectively using the 14 bits, some 15 bits only. So 2 power 15 value. So minus 32 768 to the plus 32 767 values. Okay, so one bit is assigned for the signed bit. MSB bit is assigned for the signed bit. So 0 nothing but it is a positive number or negative. Signed in is also the 60. What is the range of that value? Minus 32,768 to the plus 32,767. What are some other data types? Unsigned data types. So that we can use the uh, uh, short, long, as well as short and long data types. Yes, other data types we are using. See this table. See this. So unsigned short, short long, then signed short long, unsigned short long, signed long, unsigned long. So where you can use this one, you can use this short or long and all the data provided that is more than the 8 bits. The data that is provided more than the 8 bits. So on that time you can use the short or long short, unsigned short, long, unsigned long, or signed long, and all the cases. Okay, remember. Okay, see this again. Write the C program to toggle the bits from bits 0 1 to some bits to the 50,000 times. 50,000 times. So simply, so the toggle the values some 0 to the, so what is the, it can shows the values from 0 to the 50,000. Nothing but toggling means it is changing the values. 0 to the, so 0 to the count from 50,000. Again come to the 0 to the 50,000 again. It changes like some clock, likewise some counting clock. So again, you can call this libraries of whatever the type of microcontroller we are used here. Again, you can take the unsigned in Z. You can make the port B's and output port here. See this. Again, for Z equal 0 to what is the value they can give in 50,000. See this. But see here, this value is not able to take the entire value to the port B because there is some limitations. It is of 8-bit. So that's why you take the two different values. So two different cases. So two different. So that's why 0 to the 55 to the AA. So we can convert this x to the decimal. Remember this A means here. This is also x value. X value. This is also x value. 55 is also x value. So this A is nothing but the 10 value. A is nothing but the 10 value. So it can toggling the value. See this. Again, you can same time. So for suppose for all the bits, for suppose 10,000 times value. Same program. You just only change the here. Here they can just use the short long Z. short long z, short long z, nothing but because here the sun character, or you can take the into value x here, again 10,000 value here, nothing but sorry, it is 1 lakh value. Some again port B as well as the port A is the addresses for that ports, is addresses for that ports here. So why they are taking the long as well as a long z means here, you can see that the character unsigned long. See this unsigned long. See this. So what is the value of this one? So unsigned long. So you can use the maximum of the value. So either we are using the I mean long short also is possible. We are using the long short also possible. Unsigned short is not possible. So that's why we are using the unsigned short long. Because unsigned short value is only of 65,000. Remember, what is the value here? They can use the 65,000, but they are using the unsigned short value. That value is 16 lakh. See this. See this. See this. That value is 50,000. That's why they are using the unsigned int. Z is sufficient. Unsigned character. But here the value is 1 lakh. So nothing but that is not going to use the unsigned character. So that's why they are using the unsigned short long. So it is of 16 lakh and above. 16 lakh and above value. That's why you are using the unsigned short long set. So all are same. The only changes is this one. Okay. Again, the same some different concept is there. Small concept. Some time delay. So time delay is nothing but for suppose you want to execute some program. I want the result one in one for one in immediately and the result two in after the 2 minutes. You can count the values. Count the values. So it can display the value one after 2 seconds. It can display the value 2 seconds. For suppose after 5 seconds, it can display the value some three value and so on the time, on the situations, can use the time delay in between the operations. So use some simple loops as well as using some PIC timers for these operations. So for that one, you know that for time delaying, so for that purpose, so we are using some separate equipments or separate programs to delay that process. Nothing but so you know that microcontrollers we are using the clock is up to the 60 megahertz, 40 megahertz clock we are using. So you are not slow down the clock for showing these values. So it is not a good idea. So that's why a separate timers devices is used to delay the process for one operation to the another operations. You have to show that time delays and you can use the some oscillators for seeing the outputs, oscilloscope to measure that time delays. Okay. So whether you delay the process, you must remember the two factors. First one, so the crystal frequency connected to the oscillator's input is a most important factor in the time delay calculations. At the same time, the second one, so that affect the time delay is the compiler used to compile the C program. Okay, so again you have to see this small program, a very small program. So write a C program to toggle the values. So continuously with 250 millisecond series time delay. Whether we are using the time delay, they can specify the values like this value. 250 millisecond values. So time delay. Assume that the system is what type of control we are taking here. Then the clock frequency is 10 megahertz. Clock frequency. So you know that whether we are using for suppose 40 megahertz clock, the speed changes. So this time delays is entirely depends upon the clock that we are using. Remember, so the clock speed is not at all changing. Okay, see this. You are seeing, you are taking the we are include the libraries of PIC18 F458. Again, we are using the delay. So that purpose we are using the some syntax in the C program. You can call it as a syntax. So in the assembly level language program, you can call it as an instruction. Okay. Okay. So MS delay at the same time unsigned int they are taken. So this unsigned int signed int again that depends upon the which time which amount of time you can take it. So again, so that port B, again you can toggle the port B, so that's when make port B as an output port. So we can send the value to see this port B, you can value to the 55. So delay, how much delay you want that one? Delay 250 milliseconds delay. Again port B, you can send it to the, so these are the addresses for that one. Port B is 55 as well as AJ. So MS delay. So we, so whether it is not whether this is again you can use the delay, so you can toggle the delay. Again you can repeat some delay, toggle you can repeat the delay value. So you can repeat the delay value, that's why you are using the for loop. You write the for loop, it can be repeated until the this loop is breaks. Okay, so again we are using port D, port D, port D. Again, I think port to C, sorry, port C and port D. Yes, see this port C and port D they can give. Port C and port D they can give. Yes, same. Some port C and D you can make it as a output port for writing. This again. So these are the addresses for assigning the port C as well as port D for loading the. Again, so this is toggling. Again, this is toggling. The only changes is a port D value you can represent. See this. Only you can port D value you can represent. See this. The only difference between this program 1 to the program 2, program 2, you just simply represents the port D value. Otherwise, all the program is same. Just simply you can make the, so the same 250 milliseconds delay is appear in the same port C as well as port C. Just simply include the port D value again. So see this output value, time delay. So most of the cases we are using the stopwatches and all. How much time? We'll see this stopwatch value, total simulated value. So see this time delay. Either 251 milliseconds time delay. Okay, what is the cycles? How many cycles it will be produced by the 10 megahertz clock? Remember, they are using only 10 megahertz clock. Whether they are using 40 megahertz clock, for suppose this value is changes. We are not deciding this value. Remember, you are not deciding this value. So this value, this cycles, number of cycles produced. See this processor frequency is 10 megahertz frequency. If it is 40, this value is absolutely changed, but time is same. So we are assigning this time. For this time, so we are writing this program. We are using it as a MP lab simulator. Remember, we are writing the program for PIC18 for we are using MP lab simulator. MP lab simulator we are using. See this 255 value for 256, 251 or 250 milliseconds time. How many cycles it can produce? 60. See this. See how many cycles it can produce. 6,27,539 cycles. It will be or it will be simulated. Cycles are sampling. Instruction cycles are sampling. If it is in 40 megahertz, instruction cycles is within the range of millions is there. Okay. Okay, so that's it. While you are writing, remember, while you are writing C programs by in PIC18, you are using the software, call it as a MP lab simulator. So this MP Lab simulator is handled by the microchip company, because PIC 18 is developed by the microchip company. Okay, thank you. Thank you for joining this class.